Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at the quadratic formula and how we use it to solve quadratic equations. In the previous videos, we've looked at some other methods for solving quadratic equations. We looked at using the square root method, but it's limited in when we can use it. We can only use it if there's no x term, or b is equal to 0. We looked at using factoring as a method for solving quadratic equations, but it only works if we have something that's factorable. Then we looked at a method called completing the square, which works, and you may be asked to do it that way. But when you are doing quadratic equations and they're not factorable, they're not square root, or even if they are, most people will resort to using the quadratic formula. I first of all want to explain where that formula came from, and then I'll show you how to use it. I'm going to warn you that this is going to get a little not nice looking because we don't have numbers. But what I'm going to do is I'm going to take my quadratic equation in general form and I'm going to complete the square on this to find the solution. And that solution actually is the formula, the quadratic formula. If you don't need to know where the formula comes from, you can just skip through this part of it and just go to the part where I'm showing you how to use it. If you do need to know where it comes from, then will show you. So remember, when we're completing the square, our first step is to get rid of any coefficients for our x squared term. So I'm going to divide everything by a. So I'll have x squared plus b over ax plus c over a. Then I want to move this, my constant term, over. So I'm going to subtract c over a from both sides. Now I have an expression here that I want to turn into a perfect square, and my strategy for doing that was taking the coefficient for my x term, dividing by 2, and squaring it. So I'm going to take b over a, and I'm going to divide by 2, and then I'm going to square it. So when I divide by 2, that's like multiplying by 1/2. So that's going to be b over 2a, and I'm going to square it, which is b squared over 4a squared. That's what I'm going to add to both sides to make this a perfect square. So I'm going to add b squared over 4a squared. Whatever I do to this side, I have to do the same thing to the other side. Now I can write this as a square. It will be x plus b over 2a. It will be this coefficient divided by 2. And then this is that value squared. So it's this x plus b over 2a squared. Now what I want to do here is combine these, so I need a common denominator. So I'm going to multiply the numerator by 4a, and I'm going to multiply the denominator by 4a. So I'll get negative 4ac over 4a squared plus b squared over 4a squared, and I'm going to combine those. I'm going to put the positive term first, so it'll be b squared minus 4ac all over 4a squared. This is what I mean, it gets a little ugly looking, but just stick with me, we're getting there. Now I'm going to take the square root of both sides. So I'll have x plus b over 2a equal to the positive and negative square root of b squared minus 4ac over 4a squared. I am going to break that up, the square root over the square root of the numerator over the square root of the denominator. And I'm going to simplify that. The square root of 4a squared will be 2a. I just took the square root of 4 and the square root of a squared. Now I want to isolate x, so I'm going to subtract a b over 2a from both sides. I have a common denominator, so I can combine those numerators. And the solution that I obtain for x is what we use for the quadratic formula. This is called the quadratic formula. We can use it on any quadratic equation. The solution will be negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. A lot of times students forget to include this term in the numerator. So it's that whole numerator divided by 2a. So it's probably something that you're going to be expected to memorize, but I'm going to now look at how we use this to solve quadratic equations. Let's take a look at some examples. Our first example is one that we could solve by factoring and would be the easiest method. We could do completing the square, or we can use our quadratic formula. So the key in using it is identifying your a and your b and your c. So in this case, you can write those values down if it helps. My a coefficient is 1, or my x coefficient is a 1, so the a value is 1. B is 6, and c is negative 7. Now that I've identified those, I'm just going to plug into my formula. So x will be equal to negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a times c, the whole thing over 2 times a. So you just plug into the formula and then you simplify and evaluate. So 6 squared is 36, minus 4 times negative 7 is negative 28 over 2. And don't be canceling. I've talked about it in other videos. When you have terms, you cannot cancel them. So that's a very common mistake, but avoid it. You can only cancel factors, which means that they have to be multiplied. This is being added or subtracted. You cannot cancel. We can continue simplifying. So that becomes 36 plus 28, which would be 64. And we know that's equal to 8. So my two solutions would be negative 6 plus 8 over 2, which would be positive 2 over 2, which is a 1. Or x is equal to negative 6 minus 8 over 2, which is negative 14 over 2, which is negative 7. Those are my two solutions. We can put both back into our quadratic equation and make sure that they are correct. I would have factored this question because that would have been much easier than doing all of this. And that's why I talk about factoring and talk about it as a method, because yeah, some people are not comfortable with factoring, but if you are comfortable, it can save you quite a bit of time. Let's take a look at another example where it is not factorable, so we are required to use this method. In this next example, my variable is a t instead of an x. Doesn't really matter. It's also not in the general form. It needs to be equal to 0 before I can use my quadratic formula, so I'm just going to subtract an 8 from both sides. Now that it's of this form, I can apply my put it into my quadratic formula. Identify your a, b, and c first. So a will equal 1, B will equal negative 10, and C will equal negative 8. You don't have to do that. It's just some people find that useful. Now I can solve for T. It will be negative 10 plus or minus square root of negative 10 squared minus 4 times A times C all over 2 times A. Let's evaluate this. So that's going to be positive 10 plus or minus square root of, that's going to be 100 minus a negative 32. So 100 plus 32 would be 132 over 2. You could leave it like this, but I would guess that if you were to look up your answer, the answer you would see in your math text wouldn't be this. It wouldn't be expressed this way. If you were to find the decimal value of your answer and the answer in the textbook, they would be equivalent. But most math authors aren't going to leave it in this form. They're going to follow the convention of simplifying. And I'm going to show you how it's done. (132) has a factor of a perfect square, and that square is 4. So I can write 132 as 4 times 33. Which I can separate, square root of 4 times square root of 33. Square root of 4 is 2. I'm still not done simplifying, but I just want to give you a word of caution. Do not cancel those 2's. I see that so often. This 2 is a factor of a term in the numerator. You cannot cancel terms. You can only cancel factors, which means that 2 has to be multiplied to the whole numerator. So what we can do is factor out of a 2 out of both terms, and I'll be left with 5 plus or minus square root of 33 over 2. Now that 2 is a factor of the whole numerator, and it's a factor of the denominator, I can cancel, and my result will be 5 plus or minus square root of 33. So both are correct, but it's going to depend on what's expected of you. All right, let's take a look at this example. Again, we're going to identify our A, B, and C. We've got it equal to 0, so we're happy there. A will equal 2, B will equal negative 2, and C will equal 5. Now that we have those values identified, we plug into our formula. So negative 2, negative B, plus or minus b squared, so negative 2 squared, minus 4 times a, which is 2, times c, which is 5, all over 2 times a, which is 2. Let's simplify. So negative 2 squared is 4. 4 times 2 times 5 is 40. Four minus 40 is negative 36. That's an imaginary number, which means this quadratic equation has no real solution. And we're done. So the quadratic formula is a nice formula to use. It works for any type of quadratic equation, and it just is a matter of plugging it in. The hardest part is going to be remembering it. As usual, practice questions to develop your skill in solving quadratic equations. Take care and see you on the next one.